So I built this CNN model. I call it CNN because I was gonna replicate Lean-it 5, but I just realized while I was working on that. So they've got various versions of Lean-it from Lean-it 1 to Lean-it 5, and from my perspective, they just differ by number of layers used, like convolutional and pooling layers. Also, all these more advanced models like AlexNet, ResNet, and GoogleNet, VZZ, I think they're also just differ by number of layers being used. Also, these advanced models use um, other sophisticated techniques as well, but fundamentally, in my opinion, they just differ by number of layers. So I just call it CNN. So it would start from here. I use administrators as in Lean-it 5. I've got a helper function to print one of the images to to make sure I've been successfully loaded the image. By the way, I'm already training my model because my model is quite slow. I haven't really optimized it yet. So one of the image looks like this. This is supposed to be number 5 because the shape of dataset that's been loaded from this function is in 3D. That's because of how I created the function. Because I also recognized that while I was computing gradients, it's convenient to deal with 4D. Although in PyTorch they would also accept 3D tensors, but I just I just deal I just prefer for in I just prefer dealing datasets in 4D or yeah in CNN. So I reshaped it to 4D and I normalized it by dividing by 255 and I padded the dataset. So if I call the helper function print image again, that this one transformed to this. Next, I one hot encoded the y labels, I mean y values, true values. Next, I call the train function. This is where training begins. By the way, I declared all the parameters used in the model here, like the kernels used in convolutional layers. Um, this is not exactly same as uh, how Lean-it 5 used the number of kernels. For the number of kernels in the first layers, first layer is same 6, but I changed to in the second layer they use 16 kernels for for the second convolutional layers, but I use 10 because the model wouldn't generalize if I had 16 for my model. So, and this is the weights and biases. So inside the train function, I declared all the hyperparameters. Epochs is 10 and learning rate batch size. So from this model, I've started training my model in batches because I created a system that would train in batch. So this is where each epoch starts, and this is where each batch would start. So here I just slice the X and Y, or the data sets, into each batch size. So in this case 64. So this would slice data set into batch of 64 in every epoch, in every. Yeah, so they would, in this for loop, I would create 938 batches of data sets with each 64 batch size. But because sorry, I don't know, but so I've got 938 batches. For the last batch, it's not, the batch size won't be 64, but rather 32. So I changed the batch size to 32 for the last batch. And because I need batch size for declaring declaring one of the gradients. So once I sliced into each batches, I call forward function passing the X dataset, and this is how forward function would look like. This is almost identical to how Lenient 5 is created. You've got two convolutional layers and two pooling. And yeah, but they use average pooling, but I use max pool. And they use sigmoid function. However, I use ReLU because it's just better. And this convolution and max pool would look like this. So this is convolutional function. This is also almost identical to Com2D in TensorFlow, and I won't dive deep into how this function works. I've got a series of video called AI Devlog where I dive deep into this function. So if you're interested, but if you just think of it as like the one in TensorFlow. Also, max pool is the one from TensorFlow. So I use these functions to process the data. So this is X, pass to the convolution, and output the result, and that would be passed to the activation function. And this, I don't know, the loops keeps going, and so this corresponds to this part of the Lenient 5. This convolution is this one, this pooling is this one. And after these layers, we've got feed for neural networks. These correspond to these in my code. It's just a dense layer, like vanilla neural networks. And after that, I return not only the Y from the last layer, but also the other outputs from the layer, because I need them for calculating gradients, like here. I need these outputs for computing gradients. So after done with the forward function, we take the y value and pass it to the loss function. I use categorical cross entropy. I think that's pretty common for this type of model or data sets, like classification type model. And here comes from here to all the way down to here are all codes for computing gradients. So this is also one of the part that I want to dive deep into, and I explained it in devlog videos, so it's pretty complicated. It just essentially what we are doing is that computing gradients of loss respect to the parameters like kernels, weights, and biases, because we use them to update the parameters. That's the purpose of doing backpropagation. So we start from dl dy to these are just chain rules. So I also, yeah. So after updating, so this happens in each batches, and after all the batches are done, we go through another epoch. So 938 batches times number of epochs. So this whole thing goes like 9380 times, 9380 times approximately. So and in each batch I print the loss. Yeah. And that's it for the train function. And after that we call evaluate and predict function, which would just call the forward function we just called in train function, but with test data set this time. And in this forward function, they would use newly updated parameters like kernels and weights, because we trained these parameters inside the train function. So by the time we call evaluate and predict function, all the parameters are updated, that the loss being converged to the optimal place. So yeah, we call them, and this is I just printing the true labels and the prediction I got from the model to compare whether model has really predicted well. And I didn't mention but Yeah, I just finished. I just started training, and seems like the model has finished training. So this is how the losses look like. I think the losses are gradually decreasing from 0.2 to something to 0.002, and this is the where comparison. This is where I compare the values between y true and the one from the model has predicted. So this is one hot encoded. The value where one is marked means the category is present. So this is supposed to mean the model has to output the MNS dataset consists digits from 0 to 9. So this means that the digit is 7, and this is 2, 1, 0, and this is 4, and so on. I think you got the point. So what the model has to predict at the output is they have to output 10 values with one element marked almost 1, like this. I mean, one of the digit has to be almost 1, and this corresponds to this. So, and this one is almost 1, and all the others are almost zeros, like these. And for the next one, the third elements are marked as 1, and this is almost 1, and all the others are almost zeros. And next, I think you get the point, and yeah, looks like the model has predicted quite well I believe. So I guess this is it for today's video. Thanks.